Welcome to another Project Data Science tutorial. This time we're learning about Matplotlib, the foundational data visualization library in Python. Many of the other popular Python data visualization libraries are built on top of Matplotlib, actually, like seaborn is one that comes to mind immediately, which is why starting with Matplotlib is a great choice, even if you want to go on to learn those other libraries as well. And Matplotlib is just a hugely powerful library. Anything that you want to do, you can do it. So, here at Project Data Science, we believe that you learn best through doing, which is why all of our tutorials are hands-on. We walk you through everything step by step, but you should absolutely follow along on your own. So if you're not at your computer, get at your computer, get ready to do some coding. All right, let's walk through what exactly you're going to learn today, what we're going to do. Step number one, we're going to create a virtual environment using conda. If you don't have Python installed and if you don't have Matplotlib installed, this is where we are going to help you install that. And if you don't want to install it on your computer, we're going to show you how to use Google Colab, which is a great option for getting started. We're going to download and load some sample data into our Jupyter notebook, and we're going to be spending the rest of our time in that Jupyter notebook to make it nice and easy for you learning Matplotlib. And then we're going to go through some different sections. So I tried to break this down for you as logically as I could think to do. So section number one, we're going to discuss the basic parts of a Matplotlib graph. This can be pretty confusing to newcomers, so I spend a little bit of time here helping you get an understanding of those different pieces of the graph. Section number two, we're going to go into some basic graphs like line plots, bar graphs, scatter plots, etc. Section three, we're going to look at how to plot multiple graphs on the same axes, so on the same chart, essentially, and it's pretty straightforward. It's pretty easy to do so, like if you want to do a scatter plot and a line graph at the same time. Section number four, we're going to look at adding and altering text, like titles, axis labels, etc. Section number five, we're going to look at using subplots. What is a subplot? Well, it means plotting multiple graphs in their own different little chart areas. So we'll talk about how to do that. And then a lot of it actually is going to be in section number 6. So we're going to cover the basics in sections 1 through 5. And then section number 6 is going to cover a lot of common questions that beginners to Matplotlib have. And we're going to cover some of those common use cases that might trip you up in the beginning. And then finally, section number 7, I don't like to end a video without giving you some opportunities for future learning and some resources and some ideas for how to do that. So let's get started. First things first, I'm going to open up a terminal and I'm going to create a new, let me drag this terminal over here. I'm going to create a new directory for us to work in for this project. So this is how I like to start new projects. Let me do a little ls here, take a look at my home directory. You'll see that I have this folder, Project Data Science. I'm going to go ahead and change in here. If I do ls, you'll see these are the directories for the other courses and the other videos that we have recorded here that are online. I'm going to make a new directory. Let's call this Matplotlib. We'll call this Matplotlib tutorial. Let's just call it that. So I will cd change directory into Matplotlib tutorial. If I do an ls, you'll see that there is nothing in here, and that's because we haven't created anything in here. We just created this directory. So that's looking good. Now we're going to be using some data that we create in this tutorial, but we're also going to be using a little bit of data on heart disease, a little bit of data from Kaggle here. So I'm going to open up a new Chrome window. Let me drag this Chrome window over here. And if you go to Kaggle heart disease, let's see, we have the heart disease data set. We've got predicting heart disease. Let's go here, predicting heart disease. And actually, if we click this heart disease UCI link right there, this is the one that we're going to want. So Kaggle.com/Roni TF RONI TF and then heart disease UCI. I'll make sure to post this link so that you have it. But this is where we're going to be downloading our data from. This is a data set on heart disease. We can take a look at the description here. The database contains 76 attributes, but the published experiments for this data set only use 14 of them. And those are the 14 that we're going to have in this data set. In particular, the Cleveland database is the only one that's been used by machine learning researchers to this date, et cetera, et cetera. So this data set originally comes from UCI, so the UCI machine learning repository. So if you come here, you'll see that these are some very popular machine learning data sets. So we're going to be using this heart disease one here, but we're just going to get it from Kaggle. So let's go up here, click this download button. If you don't have a Kaggle account, you'll probably need to create one. I will click on this zip file that gets downloaded. It opens up this heart.csv. I'm going to rename this really quickly just to what the zip file was named, actually, which was heart disease UCI. And now, just to show you how to do this in the terminal, I'm going to come back over here to our directory, our Matplotlib tutorial, which if we go to Project Data Science and Matplotlib tutorial, you'll see that this is right here. And I'm going to move MV from our downloads, heart disease UCI.csv, and I'm going to move that to just period, which means this directory. So I move that and do a little ls to show that we have our heart disease UCI.csv file in here. Okay, so now if I go and I double check that our CSV file really is there, I'll go ahead and double click this. We can pull it up in Excel really quickly just to take a look at what it looks like. All right, just a bunch of numbers. See a bunch of numbers here, and we have our column headers across the top. So we have the age of the person, the sex of the person. These are ones and zeros, and the original or the Kaggle data set over here gives us the mapping. So 1 equals male, 0 equals female. And then we've got these other numeric columns as well. And this is what we're going to be plotting for some of the tutorial. So coming back over here, let's go ahead and close this and go ahead and close this. Now we get to the part where we need to set up our Python environment. We need Python, we need Matplotlib. In this case, we're going to need pandas to read in the data set, and we're going to need Jupyter for our Jupyter notebooks here. So there are two different options. Number one, I'm going to be creating a conda virtual environment using the conda create command here. If you want to go this route as well, then I suggest if you don't already have Miniconda or Anaconda installed, go over here to the Miniconda page. Conda is a virtual environment manager and installer for Python. So we are going to use Conda to manage our virtual environments. And if you don't know what virtual environments are, feel free to do a little bit of research there. But essentially, it's a best practice for wrapping up our Python coding environment into a single directory so that we don't, screw up our computer and et cetera. And so we don't have conflicting packages as well when we try to install things. So if you want to go this route, install Miniconda, and we will install everything that we need into a folder, and it just takes a second here. If you don't have Python on your machine and you don't want to go through this installation process, which I do recommend if you're interested in data science or data analysis, having Python on your computer is very helpful so that you can actually run some Python and stuff. But you can also go to Google Colab. So Colab, these are essentially Jupyter notebooks run by Google in the cloud here through your browser. So with these, you would not have to install anything. You can just come here to Colab. You can create new notebook, This is going to create a notebook for you, and it's going to have everything that you need installed. So it's going to have Matplotlib, it's going to have pandas, etc. So if you want a nice, easy way to get started here, you can just go to Colab and use a notebook in the cloud. So that's pretty cool. I'm going to go ahead and move this to the trash because I'm going to be doing this on Jupyter Notebooks on my computer. Leave this site. All right, we got this mini conda here. So let's come over here to conda create, and I'm going to create a new virtual environment. I'm going to call it Matplotlib tutorial. And so that's this -in flag here is the name of the virtual environment we're creating, the conda virtual environment. And now I'm going to install the Python packages Jupyter, Matplot. Let's go ahead and full screen this, why don't we? Matplotlib, pandas, numpy. I think that should be it. And if we click run here, this is going to spin for just a second. It's going to look at all these packages that we're trying to install, figure out if we can install them, and then we will hit the letter Y right here. So this is going to tell us everything that conda needs to install in order to install the 4 different packages that we want to install in this virtual environment. So I type a little Y for yes, hit enter. This is going to download and extract these packages, and we will give it just a minute to finish. Perfect. So we've just created a conda virtual environment called Matplotlib tutorial. Everything finished installing just fine. So one way to see which virtual environment you're using, or rather which version of Python you're using, is if you're in a terminal here on Linux or Mac OS. This command is going to be a little bit different on Windows. I believe it's called where if you're in CMD, the command prompt. In PowerShell, it might be a little bit different, like where.exe or something like that. But so you type which Python, and this is going to show you if I were to run Python right now. So I run Python. This is the executable that's getting called when I run Python. So Anaconda 3 bin Python. And you'll notice that this is Python 3.7.3, et cetera, et cetera. I have access to all of the packages that are installed in my base Python installation through Anaconda. Now, if I exit out and I conda activate Matplotlib tutorial, just like it says to do up here to activate the environment, you'll notice that this changes over here on the left to show us that we're in a different environment now, and your terminal might not have that. That's okay. I have the terminal ZSH, which does some fancy stuff like this for me, but that's fine if yours does not. Now I type which Python, and you'll notice that we point to a different location. So Anaconda 3 invs Matplotlib tutorial bin Python. This shows that we are now inside of our wrapped up virtual environment, and we only have access to the packages that we explicitly said we wanted to install, in addition to the standard Python packages. So I type Python here. You'll notice that we're actually running a different version of Python in here, 3.8.3, because conda, whenever you create a new virtual environment, I think it just pulls the latest version of Python, the latest stable version. So we're actually running a newer version of Python. If I import pandas, we installed that. So pandas can import just fine, but we did not install seaborn, which is another data visualization library. So seaborn is installed in my base installation, but it's not installed in my virtual environment because we are using a totally separate Python installation. We're using totally separate packages here. All right. So what I'm going to do now is I'm in my Matplotlib tutorial folder. I'm going to run Jupyter Notebook and we're going to do the rest of this Matplotlib tutorial inside of our Jupyter Notebook here. So let's go ahead and close out of this other Chrome window. So this is our Jupyter Notebook interface. I'm going to to open up a new Python 3 notebook. Let's name it Matplotlib tutorial up here. And we are good to go. The first thing we're going to do here is I'm going to create a markdown cell by typing the letter M, and I'm going to get into here and make a header 1, and I'm going to say set up notebook. So the first thing that I like to do in a notebook whenever I'm doing data visualization using Matplotlib is you do this %sign Matplotlib inline. So we don't have to spend too much time on this right here, but essentially there are different ways that you can run data visualization in Matplotlib. And in Jupyter Notebooks, Matplotlib inline is going to be one of your most popular, most common choices. I would just set this up, put it as one of the first cells in the notebook, and then kind of forget about it. So let's get closer to diving into some actual data visualization here, because the thing about Matplotlib that you will very quickly learn is there is so much power that it can be overwhelming, and there are so many options that it can be extremely overwhelming. So I'm going to try to start you off with some of the simplest stuff that we can do, and then we're going to add on complexity there. But I definitely want you to limit the number of things you're thinking about originally. So let's go ahead and get started. So import matplotlib.pyplot, and this is the main plotting submodule here that we're going to use. Matplotlib has various other submodules, which you could see by typing tab, by hitting the tab key. And then you can see all of these different submodules that Matplotlib has. There's a ton of stuff here. But anyways, pyplot, and then we import it as PLT. And this is going to be the way that you're pretty much always going to import Matplotlib here. So let's go ahead and run this. Now I'm going to create a new markdown cell here with a new heading 1, and I'm going to say section number 1, pieces of a Matplotlib graph. To start off with, I want to be nice and explicit here so that we see exactly what we're plotting. So I'm going to say x. Let's just create some data to plot. So I'm going to say x equals, and I'm going to create a list here, -3, -2, -1, 0, 1, 2, 3. We could also do this with the range function in Python. That's totally fine. And I'm going to import numpy as np while we're at it, because Matplotlib usually expects a numpy array. And a numpy array, if you haven't worked with numpy much before, is, you can basically think about it like a list or a matrix. So you can have a one-dimensional array, which is just a list, or you can have a two-dimensional array, which is more like a matrix with rows and columns, and you can have three-dimensional arrays and things like that. So I'm going to create x equals np.array, -3 up to +3. And now for our y, let's create x squared. So we're just going to do a simple x and y squared thing here. So if we look at x, we have our array, -3 up to +3. And if we look at y, well, we just squared every single number here. So 9, 4, 1, 0, 1, 4, 9, etc. So to create a plot in Matplotlib, this is the basic formula that I am going to recommend you always use when you're starting out. There are other ways to do it, but we're not going to talk about those right now. We're just going to I'm going to give you a formula that you can use to plot, and I recommend that you always do it this way for now. So to start off with, you're going to say fig and x equals plt.subplots. And then you're going to do all of your plotting code here. So do your plotting code here, dot, dot, dot. So this is where you're actually going to say what you want to plot. And at the very end, do plt.show. So this is the formula. This is your plotting formula here. So I'm going to even create a little section 3 header down here and say your plotting formula. All right. So what we're going to do is we're going to say fig ax, and this stands for figure and axes, not axis, but axes. This is kind of a confusing thing we'll talk about in just a minute. Fig ax equals plt.subplots. We'll do plt.show, and now our plotting code that we're going to do first is just ax.plot x and y. And here we go, our first Matplotlib graph. Beautiful, isn't it? It's actually kind of a little choppy. It's actually, kind of ugly. But with this just a little bit of code here, we're able to produce graphs. And this is pretty cool. And from here, we're going to add on complexity layer by layer. But this is the foundation of plotting in Matplotlib. You always instantiate your figure and your axes. You always want to end it with plt.show, unless you're saving out a file rather than displaying it here. And then in the middle, this is where you're going to do all your plotting. And you can have, you could have one line here to plot this, or you could have 100 lines to do all kinds of crazy formatting. So this is a good place to tell you, what do these terms actually mean? And to do that, we're going to go to the handy dandy Matplotlib parts of a figure. Anatomy of a figure. Let's see. Here we go. This is exactly what I wanted to look at. So this is what a Matplotlib graph is, or a Matplotlib figure. And if you understand what it is, this is going to help you with plotting. So let's talk about the main pieces here. The figure. So you notice this circle here pointing to just what looks like a blank patch of nothingness. That's because the figure, the Matplotlib figure, is this whole graph. So it doesn't matter how complex your graph is. It doesn't matter how many different lines you have in here and how many different points. And you can actually have lots of little different graphs in here as well. The whole thing is called the figure. Now, within a figure, you'll notice right beside it here, axes, A-X-E-S, axes. This is what we might think of as being the graph itself. So the figure is where you're going to put all of your graphs. And then the axes is going to be kind of the plot itself with an x-axis and a y-axis and some lines and some points and all this kind of stuff. So to make this a little bit more clear, let's come back over here, and I'm going to show you now what it looks like to have a single figure with two axes. So subplots, and in this case, I am going to do one row of two columns of axes, and I'll explain this in just a second. But here we go. So now we have a single figure. Now, a figure being just like this image here. You see how I can kind of click and drag that image? So this is like a single image file that you could download here. That whole thing is your figure. Now, your axes, A-X-E-S, this is going to be this plot. So this plot right here is one axis. This plot over here is another axis. So we have two axes, and this is what I created here. I created one, which is the number of rows of axes that I wanted, and two, which is the number of columns of axes that I wanted. And then I took each one of those axes and I plotted on it. And this is why up here we had one axis and we plotted on that single axis x and y. So x versus y, -3, -2, -1, that's your x. And then 0 up to 0, 1, 4, 9, etc. That's your y. So down here, we have a single figure still, but now we have two axes. All right. Now, within each axis, with an ES, and this is very confusing. They probably could have done a better job naming things here. You have your x-axis and your y-axis. So this might be what we typically think of as an axis. And then for each axis there, you can have an axis label, you have axis tick marks, you have grid lines on that axis, and then same thing for your y-axis up here. And then you have your actual plots. So you can have a line plot, you can have markers for like a scatter plot. So in our case over here, we have axis 1, which has its own x-axis and its own y-axis. And maybe to make this clear, let's plot x cubed on the second one here. So x cubed is now going to be in this axis over here. So you see that each one has its own x-axis, and its own y-axis. Each one has its own lines, its own line objects in here. And this is all wrapped up in a single figure. All right, so I hope that that's helpful. First off, we create the figure, and we create the axes, and then we plot things on the axes themselves. And then finally, whenever we're done getting all of our stuff to plot, we show it. We show the graph. Okay, so hopefully this is somewhat clear for you at least. I think that people honestly use Matplotlib for years without ever looking at this figure here and seeing what all the different pieces are. So remember that the graph, the whole thing is called a figure. Within each figure, you can have multiple axes, which are where you actually do the graphing. Each one of those axes has an x-axis and a y-axis, and then that's where you're going to do your line plots, your scatter plots with your markers, etc. And just to really drive this home, so I'm going to copy this down here, and instead of making a 1x2 grid of subplots, I'm going to make a 2x2 grid of subplots, and let's just plot this. Let's show this before we do any plotting on the axes themselves. So I'm going to create a comment here and just say create a figure with 4 axes. Let's see, 2 rows of 2 graphs on each row. And here we go. You'll see that we have a single figure. So if I want to drag this, you see that that's kind of just like a single image there. And we have 4 different axes. We have a 2x2 grid of axes. Each one of those axes has its own x-axis and its own y-axis. And we can plot whatever we want on these axes. And this object, the AXS that it returns in this case, since we have a 2x2 grid, is actually also going to be a 2x2 NumPy array for us to plot on. So to plot, I'm going to use kind of 2-dimensional indexing in here to show you how we can plot things on these graphs. So I'm plotting things on the 0th row, the 0th column, so this one, and then the first row and the first column, this one over here. We could also plot things on 0, 1 and 1, 0. And I'm doing all of this, by the way. So let's maybe do an x to the 4th, and what do you think? Like a log of x or something like that. Let's try this. Okay, we got to divide by 0 in the log. Let's do an exponential maybe. Here we go. So you see we've got 4 different graphs now in 4 different axes, and they're all inside of a single figure. So everything inside of a single figure. All right, so the reason why I'm really trying to drive this home right now is because everything else that you do in Matplotlib is going to rely on you understanding these axes objects and the fact that you're plotting on these axes objects. So if you want to plot some, two images side by side, well, you now understand that these are two different axes on a single figure. If you want to plot two different graphs on the same axes, well, now, even though we haven't done this yet, you might be thinking to yourself, okay, I know I'm going to use that same axes to do that plotting. And this is something that we're actually going to get to in just a minute. So before we move on, I want to show you one last thing while we're here, and that's the fact that you might notice that these graphs are pretty choppy, right? You're like, oh, well, this doesn't look like a very pretty parabola. It's kind of choppy. Are all the graphs going to be this ugly? And the answer is no. The answer is that the graphs are choppy because these are the only points we gave to Matplotlib to plot. So to make this very clear, I'm going to introduce something that we haven't looked at yet, and that is the scatterplot. That's the scatterplot. So with the scatterplot, you can really see it now that we have only defined x and y points. Remember, we've only defined x and y points, x and y, for 7 data points total. So we've got 3 in the negative, we have 0, and then we have 3 in the positive. So that's why we have so few data points. And then when you connect these points with a line, well, then you end up getting a kind of choppy looking graph here. So to show that, let's see what it would take to create a smooth line. And to create a smooth line, I'm going to use the NumPy method, or the object here, arange. And if you've never used arange, you can use one of my favorite Python tricks, the question mark here, to get the documentation. So np.arange, here's the doc string. You give it a start, you give it a stop, and you give it a step, and then it returns evenly spaced values within a given interval. So the start number, the stop number, and then the spacing between values. So let's, for example, create a range from -5 to 5, and let's space them out by 0.01. And if I run this, you will see, boom, wow, tons of values. That is a lot of values. How many values is that? Well, that is 1,000 values. Perfect. So let's create this as our x instead. And now let's do the same thing that we did before. Y equals x squared. Now, if we plot x versus y like we did before, now you see we have a very smooth graph. And why is that? Well, that is because if we plot the scatter plot, again, of x versus y, you see each one of these is a point. So we now have 1,000 data points here defining this graph rather than a measly 7. This can be something that confuses people whenever they first start using Matplotlib. They're like, hey, why does my graph look the way that it does? And well, it's because of this. It's because of how many points you pass to Matplotlib, asking it to plot. So in this case, we're only passing 7 points. In this case, we're passing 1,000 points. And we get this really beautiful graph here. Actually, I'll show you. Let me show you. Let's create a y. Let's create a y damped oscillation. Is that how you spell oscillation? I think that is. Oscillation. You always forget your spelling and things like this. Damped oscillation. So I'm just doing this because it's fun and it's pretty. So I'm going to show you really quickly what a nice, pretty graph looks like. So we do the e to the negative x times cosine of the np.pi, whatever. You don't have to know any of this, by the way. This is just for fun. So we create our y. Now let's do fig ax equals plt dot subplots. Let's do ax dot plot x versus y damped oscillation, plt dot show. And look at that. Isn't that pretty? Isn't that nice? And we have 1,000 data points here. that are helping to show this graph, which is why it looks so nice and smooth. All right, that's enough of the introduction, I think. I hope that you have gotten a better sense of the pieces of a Matplotlib graph. I'm going to copy this under this section header just as a nice little reference. Let's save our Jupyter notebook and let's move on. I'm going to create a section header here in Markdown. I'm going to call it section number, I guess this is section number 2 now, isn't it? Section number 2, basic graphs. All right. So let's do some of the basic types of graphs that you might want to work with here. And actually, you know what? We haven't started using our heart disease data yet, have we? So let's actually scroll back up to the top. I'm going to create another header here, and I'm going to say load our data. Okay, so we're going to load our data using pandas. And if you have not used pandas before, and if you haven't seen the Project Data Science Pandas mega tutorial, the Pandas mega tutorial, that will walk you through pretty much everything that you need to know about pandas. So I would highly recommend watching that at some point. But let's go ahead and just import pandas as PD. And we're going to use pandas to load the data. So let's type in ls, which handy dandy Jupyter notebooks converts into the shell command, or it uses the shell command here. And it lists out the files that are in the current directory. So we see our heart disease UCI dataset. So I'm going to load this pd.readcsv into a data frame. So let's read that in. If we look at df.head, this will give us the top 5 rows in our data. So we see that we have our age, sex, we have this column called CP, et cetera, et cetera, et cetera. And then target is whether or not the person had heart disease. If we look at df.shape, this will tell us how many rows we have and how many columns. If we look at df.describe, this will tell us some descriptive statistics for each column. So for example, our average age is 54 in this data set. And if we go over to targets, the average prevalence of heart disease is about 54%. So the majority of the people in this data set do actually have heart disease. Finally, if we look at df.info, this will tell us the number of non-null rows. So in this case, we have 303 rows. Looks like all of our columns, none of them have any nulls, and all of them are numeric data types. One of them is a float. The rest of them are ints here, integers. All right, so we've loaded our data. We're ready to start plotting using this data now. So we'll come back down here to our section number 2. Section 2, basic graphs. So let's start with a scatterplot. Start with a scatterplot. So if we take a look at our data frame, and maybe we want to take a look at the scatter plot of 2 of these columns plotted against each other. So maybe we're interested, is there a relationship? Is there a relationship between age and, let's say, your cholesterol level? So that's the question we're interested in answering. So I'll actually type that in here. Is there a relationship between age and cholesterol level? So if we look at df age here, this is going to return a pandas series. We have a bunch of values. We can convert this to a NumPy array, which is used in plotting Matplotlib here. And actually, I think Matplotlib can also take pandas series as well. But, you know, never hurts to convert it to a NumPy array first. And then let's look at the first 10 values here. So the first 10 values of our NumPy array. And let's also look at cholesterol. Let's look at cholesterol. First 10 values here. All right, so we want to make a scatter plot Following the same, the formula that I told you up there, the formula for plotting a Matplotlib, let's do fig, comma, ax for axes equals plt dot subplots. We'll do ax dot, we have been doing ax dot plot, but all we have to do is change it to ax dot scatter. So instead of doing a line plot, we're now going to do a scatter plot. And we'll pass in our what we want our x to be. So x is going to be the age, and then we'll pass in what we want our y to be. So the y is going to be our cholesterol. And then finally, plt.show. And here we go. Here's a scatter plot of our age versus our cholesterol. And at a glance, there doesn't appear to be too strong of a relationship. There might be a slight positive relationship here, but nothing that jumps out and slaps us in the face. So let's, maybe we're interested in not every data point that we have in our data set. Maybe we're interested in the average by age. And this will actually give us fewer points to work with as well. So I'm going to create a data frame that is grouped by age. And so essentially what we're going to do, df.group by, we're going to group by the age, and then we're going to take the average of all the other values. So if I do that, and I explained this more in the pandas tutorial video, but essentially what's going on here is we're grouping all of our data by the age. And then, for, let's say 40-year-olds, or let's see, maybe for like 45-year-olds, we'll have 10 different data points. So we're going to take the average of those 10 data points to get each one of those values. So this cholesterol value here, rather than being the cholesterol for a single individual, is now going to be the cholesterol, the average cholesterol for all 45-year-olds. So let's take this group by. We'll set this equal to df group by age. Let's just call it something so that we can use it. And then if we look at this data again and ask ourselves, okay, now we want to plot age versus cholesterol. Well, our age is now our index over here on the left side. So this is kind of a special feature of pandas data frames. And then our cholesterol is still just a column. So if we look at df group by age dot index, here are all of our ages. So this is going to be our new x. And if we look at df group by age cholesterol dot values, and we'll just look at the first 10 of those. All right, and maybe we can look at the first, 10 from the index as well. All right, so let's create a second scatter plot. So we'll say scatter plot number 2, average cholesterol by age. All right. So we can take this exact same kind of scatter plot formula. We'll put it down here. And now instead of df, we're going to have df group by age. df group by age. And rather than calling the age column, for this one, we're going to pass in the index. And this df call will stay the same. So let's plot this. And see, there you go. So now we just have a single data point for each age, and we get something that actually does look much more like a positive correlation here. So that is scatter plots in a nutshell. ax dot scatter. And we're gonna go into more depth with all of this graphing as we go along, but we're starting with just the question of how do you plot some basic graphs. So first up, scatter plot. Now let's talk about a line graph. So what if we wanted to take this same plot here, but rather than plotting it as a scatter plot, what if we want to connect the dots? We want to plot a line graph similar to how we did up top with the y equals x squared. Well, we can just copy this down here, and rather than ax.scatter, we've done this before, ax.plot. And there we go. Whether or not it makes sense to represent this data this way, that's your judgment call to make. But to plot a line graph, all you have to do is call ax.plot. Okay, so let's move on to, let's do a bar graph. What if you want to plot this as a bar graph? Lots of things look really good as bar graphs. It's very easy to tell relationships between different categories in a bar graph. So this is a very common type of graph. How do we do that in Matplotlib? Once again, let's go ahead and copy our formula for graphing down here. So we create our figure, we create our axes using plt.subplots. And now, rather than ax.plot, we just do ax.bar. So you can see that we're changing the type of plot here by changing the method that we call on the axes object. So we have our axes here where we want to plot something. And then to actually plot something, we got to call some sort of method on it. And to do a scatter plot, you call .scatter. To do a line plot, you just call .plot. And .plot is more powerful, by the way. You have a lot of different options actually for each one of these methods, but we're just going through the basic method right now. And then for a bar graph, you just do .bar. And all the time, your first value here is going to be your x, and your second value is going to be your y. That is going to change slightly with a horizontal bar graph, which we're going to do next. So let's do a horizontal bar graph here. And so instead of calling bar, now we call bar h. So we call bar h. And now, so this is where it mixes it up a little bit. This first argument that you're going to pass in, you call it the exact same way here, but now this first argument that you pass in is technically going to be your y-axis, and the second argument that you pass in is going to be your x-axis. So now you might be thinking, okay, well, hey, how do I see how many methods I can call on this axes object? So if you go out to a new cell, and I believe we still have this AX object from the previous cell here. If we do AX, we type dot, and then we hit tab. So this will show us all of the different attributes, all of the different methods that we can call on our axes object. And you'll see that there are quite a lot. So here's bar H. You can see that we've got a box plot there. You can see that we've got various things for dealing with labels and zooms. We have error bars here. So you have all kinds of different things. And this is, partially, I'm just scrolling through this massive list right here. This is partially what I said whenever I started the video about Matplotlib can be overwhelming. There are so many options because you can tweak this graph to look however you want it to look. So there are a ton of options here, which is why we're starting kind of nice and simple and building up complexity as we go. And there will still be a ton to learn after this video. So, it's all about just how do you want the graph to look and how do you get Matplotlib to do that. So let's keep going with simple types of graphs. This is going to be our last one, is a histogram. And for a histogram, you just need one variable. So a histogram buckets your data into different bins and then shows you how many of your rows of data fall into each bin. So in this case, maybe we want to look at, let's go ahead and copy our kind of plotting formula down here. Maybe we want to look at our age distribution. So how many people in our data set fall into which age buckets? So in this case, we just call ax.hist. So .hist is the method that we're going to call here for histogram. And by the way, if we wanted to look at that doc string, if we wanted to look at the documentation for hist, we just put the question mark after it. We run that cell, and then you see, okay, what do we pass in here? Well, we pass in x. X is the only thing that's required, and all of these other parameters are optional. They all come with defaults. So bins is one of the parameters that we can use. We can plot a histogram, okay, compute and draw the histogram, et cetera, et cetera. Bins, here's the description for that parameter. So If you want to do something like plot a histogram and you want a little bit more control, slap this question mark here, run this cell, get the documentation, and see what all your options are. And you can set some of these right whenever you first plot your histogram. So, all right, so we want to look at our histogram for our age. So in this case, we're going to go back to our original data frame that has all of our rows, that has one row for every person in this data set. And let's go ahead and get the values here for the NumPy array. And here we go. Here's the histogram of how many people in our data set fall into each age category. So you can see here that we have, most of the people in the data set kind of fall into this cluster right here. Actually, we've got two big clusters here. One of them is from, what is this, like 53 up to 67 or something like that. And then the other group here from, late 30s up to 50, 53, early 50s, something like that. So that is how you do a histogram. And with that, you see we have a number of different chart types here that you can access all just by calling these different methods. And if you remember, scrolling back up to these 4 different subplots that we had, these 4 different axes. So if you wanted to do a different type of plot in each one of these, you could. And, I could just show you what that looks like right now, actually. So what if we change x to the 4th to a scatter plot? There we go. Well, so we have a lot of data points here. Oh, it's because we changed our x and our y. We changed our x and our y to have a lot of different points, to have 1,000 different points down here. So that's why this graph is now going to look pretty different, which might actually not be super great for these next types of plots, but let's try it anyways. Let's try a bar plot. So this is going to try to do a bar plot with 1,000 different bars, which, yeah, it's not the greatest, but there you go. And so this is how you would do different types of plots in your different subplots here. It's as easy as changing the method you're calling. Okay, so that wraps it up for the simple graphs here. We have scatterplot, we have a line graph, we have a bar graph, horizontal bar graph, and a histogram. And with those plots, I think you're going to be able to do most of the types of plots that you want to do, especially when you start kind of mixing and matching these and learning how to use color and all of that. So let's move on now to the next section. So let's create a new section right now. Let's call it section number 3. Section number 3. And so for this section, we're going to look at plotting multiple graphs on the same axes. So the same axes. So remember, fig ax equals plt.subplots and then plt.show. This is going to give us one figure, so one image, and one axis, so axes there, so one place where we're going to plot something. So for this one, we're going to look at multiple graphs on the same axes. So we're not going to be looking at multiple axes like this. We're going to be plotting on the same axes. Okay, so let's try a simple plot first. Let's go back to our simple mathematical equations that we were using earlier. So we'll do ax.plot, and let's take a look at our x. So our x is still there. Our y is still there. Let's take a look at x and y here. What is this? This is a parabola. All right, beautiful. Now, if we want to plot another thing on here, let's do ax.plot. Let's go back to our damped, y damped oscillation, remember? And there you go. So our parabola got very squished here, you can see, because our y-axis suddenly got very big. So what if instead of a parabola here, what if we do like x cubed? Let's try that. All right, so that looks a little bit better there. But Either way, you can now see that we have two graphs on the same axes. We have y equals x cubed, and then we have our damped oscillation graph here. And Matplotlib went ahead and plotted these in two separate colors for us. Now, whenever you start plotting things on the same axes, you very often want to add labels. And this is very easy. You just add a label parameter inside of your graph here. And so we can say, you know, for this one, maybe this is just x cubed. And maybe the label for this one is damped oscillation. So we add labels, but if we run this, nothing else happens. So this is where our handy-dandy ax.legend method comes in. So this is something that you'll probably use all the time. Anytime you add labels to your graphs, and then you want to show those labels in the graphs, just add this ax.legend. We run this. Matplotlib automatically puts a legend down here for us with the color, and it'll put the style of the graph too. So, you know, if this was a scatter plot, these would be little dots rather than lines. And we see that our blue plot here is x cubed, and our orange plot is the damped oscillation. So that's a simple overview of how you use the same axes object to call the plot method multiple times. You call it multiple times with different data, and that plots your data on the same axes here. Now let's go back to our heart disease data. And let's say that we want to have a scatter plot. So we want to go back to a scatter plot of plotting one numeric variable against another to look for a relationship. But we also want to color by labels. We want to color by labels. So why might we want to do this? Well, let's say that we want to look at the relationship of, let's go back to our data frame. Let's say we want to look at the relationship between T rest BPS, which if we go back to our Kaggle data here, back to our Kaggle data, T rest BPS, this is the resting blood pressure. So this is the resting blood pressure. And then cholesterol, this is the serum cholesterol in, was this milligrams per deciliter or something like that. So let's say that we want to look at the relationship between the resting blood pressure and the cholesterol. And we want to see if there's any difference in that relationship as far as people who have heart disease and people who don't. So we want to color by people who have heart disease. Let's take a look at kind of what we mean here and how we might do that. So we'll start with our basic formula. So we've got our subplots here. We're creating our figure, creating our axes. At the very end, we call plt.show to show that plot. And now if we just wanted to do this normal scatter plot, if we just wanted to do a normal scatter plot, we might say, you know, df trest bps dot values, and we want to plot that against cholesterol dot values. And here is our plot. We've got that resting blood pressure on the x-axis. We have our cholesterol on the y-axis. But we want to color this. We want to color this by if the person has heart disease or not. So looking at our original data here, you can see target. So target of 1, and let's just go back to our data to verify. A target, let's see. All right, experiments with the Cleveland database. So values 1, 2, 3, 4 all indicate heart disease, and a value of 0 indicates no heart disease. I think in our data here, we just have, value counts. Yeah, we just have 1s and 0s in our data here. So 1 indicates presence of heart disease, 0 indicates absence of heart disease. So we want to color by this column. So we want to color each point by whether it's heart disease or not. So using this, we can use the same principle of plotting multiple graphs on the same axes. So in this case, let's say, let's take a look at our target. Let's say we want to get only the rows where this equals 0. So we set this equal to 0. That creates a Boolean mask here. So essentially, does this row equal 0? And it says false or true. We pass this Boolean mask back into our data frame in order to index down to just these rows here. And then we could call this, we could call this like our df subset or something like that. So let's try to go through this whole thing up here. So df subset equals this. And now, rather than passing in the whole df, maybe we just want to pass in this subset. So these are just going to be the rows where the person does not have heart disease. So let's say first plot the data where the individual does not have heart disease. So let's do this scatter plot first. And there you go. You see that the scatter plot thinned out pretty nicely there. So we're only plotting about half of our points now. We're only plotting about half of our data points. So let's copy this whole thing. Let's copy this whole thing and go down. And now maybe we set df subset equal to where the person does have heart disease. And then we can plot again. So second, plot the data where the individual does have heart disease. And look at that. Matplotlib already colors these points differently based on whether or not the person has heart disease or not. And now all we have to do is, like we did before, let's add a label. So let's say label equals, we'll call this maybe healthy, and this label will say heart disease. And remember that we need to add our handy dandy ax.legend down here. And there you go. So essentially what we've done here is we've plotted two different scatter plots on the same axes. The first one, these are the x values and these are the y values of the healthy patients. The second one, these are the x values and these are the y values of the patients with heart disease. Matplotlib automatically does the coloring for us, and we add a label and we add a legend. And there you go. We now have a scatter plot where we're coloring by labels. That's pretty cool. Now let's say that we had a lot of values here and we wanted to do this same kind of coloring scatter plot for a lot of different values. Well, this is a lot of redundant code here, and it is very clear because we're explicitly spelling out, hey, plot this first and then plot this second. But there is another way that we could do it, and I want to show you that really quick. So I'm going to copy this down to the second cell. So in this case, we're going to loop through our different values. So basically, the only thing that changes in this code, other than the label that we set, is the way that we filter our data down based on the value of target here. So if we look at df target again, df target, if we want to get the unique values in this series, then we just do .unique. And this shows us that we only have two unique values, 0 and 1. And then we can iterate through these. So what does that look like? Well, we can say for target value in df target.unique. So we're going to loop df target. There we go. .unique. So we're going to loop through each target value through 0 and 1. Let's go ahead and indent this. And now, rather than setting this equal to 0 explicitly, we're going to set this equal to the target value that we're iterating through. And I'll delete this comment. And while we're at it, I'm going to remove this label for right now. And we can delete this second plot here. So let's, and then maybe actually I will pass in, I'll pass in label equals target value. And then we'll keep the legend here. And there you go. So we just did the exact same plot, except for you'll see that now Matplotlib, because of this dftarget.unique, it has switched the order that we're plotting, which means that the colors are flipped here. So 0, or healthy is now orange, and heart disease is now 1, just because of the ordering that these values come out of dftarget.unique. And our label is now just this target value. So if we wanted to have a more descriptive label here, this is where you could start doing something like this. So maybe we have a dictionary. Maybe we have a dictionary called label mapping or something like that. And we want to map a label value or a target value of 0 to healthy. And we want to map a target value of 1 to heart disease. And now, rather than our label equaling the target value, we'll have our label equal label mapping of the target value. So I run this cell so that we get our dictionary. And now if I run this again, you'll see that we're passing in our label, which is mapped from this dictionary. And this is a kind of trick that you can use in a lot of different situations. We could have a color mapping dictionary here, where maybe if the label is 0, we want that to be blue, and if the label is 1, we want that to be red, or something like that. So you can do all different kinds of mapping tricks with dictionaries like this. But this is an example of how you could take 2 explicit calls, if you wanted, and turn them into one for loop call that iterates over all of the unique values. Now, while we're on this scatter plot, let's say that we have one specific point that we want to call out somewhere in this scatter plot. This is something you might want to do for various reasons. Maybe you want to call out a single bar in a bar chart, or you want to call out a single point in a scatter plot. This is a pretty common thing to want to do, so let's talk about how to do it with this scatter plot. So I will say scatter plot, calling out a single point. And in this case, the way that we're going to call it out is using color. So if we do ax.scatter ? Let's see what options we have here. So in addition to passing in x and y, which we've been doing, we have an s parameter, a c parameter. We got a bunch of other parameters here. So s is going to be the size, the marker size here. And c is going to be the marker color. So we're going to take advantage of that marker color in just a second. So let's start with our normal template here, plt.subplots. Let's do ax.scatter and let's do ax.scatter, and we're going to do all of the points here. So let's do df, trest, bps, df, cholesterol. Let's take a look at this. All right, now let's say that we want to call out a single value. So first off, let's put all these other values as kind of a light gray. So I'm going to use the c parameter. C equals light gray. So c equals light gray. So we just turned all of these points light gray. Now we want to call out a single point here. And maybe the point that we want to call out is just the first patient in this data set. So what we can do is we can just have a scatter plot of, and actually I'm just going to copy this whole line down. Let's have a scatter plot of just the 0th index person. So just the first point in our data here. And now let's change the color to red. And there you go. You see now that we plot all of our points in a light gray color, and then we just take the first point. We just take that first point, the 0th index here, and we plot that specific point in red. So this is a very nice way, and you can do this with bar graphs. You can do this with other types of graphs. This is a very nice way to call out specific points in a graph is you just plot another scatter plot right on top of it. Do it in a different color, whatever color you want. Okay, so our last example in this section is going to be, let's do a bar chart with a line graph and maybe a horizontal line as well. So we'll start off with our same template, plt.subplots and plt.show down here. So what data do we want to plot? Well, maybe I want to plot, let's see, maybe I want to plot a line graph of, let's go back to our group by age. So let's plot age along the x-axis, and maybe let's plot our cholesterol levels along the y-axis. So here's a nice line graph showing your age and your average cholesterol per age group. So now maybe I want to add a bar graph on this axis here, and I want to show the T-rest BPS, the resting blood pressure. So now let's do ax.bar, and once again, just to kind of reiterate, we're using the same ax object here. So we're taking the same object, calling different methods on it here, so that we are plotting different plots on the same graph, the same axes. So we'll also use the age as our x-axis. And now let's do the T-rest BPS as our values. And there you go. Look at that. We now have this bar graph, which represents one value, and the cholesterol, which represents another value. So that's not explicitly called out here, so we could change the color of these different graphs here. So maybe I'll pass in a C equals, let's try orange, and we can leave this color the same. Let's pass in a label and see what that does. So this will be cholesterol, and this label will be T-rest BPS. And remember that we need to call ax.legend in order to get that legend to show up. And so there you go. This is what I was talking about earlier as far as the graphs will show up as different, they'll show up as different shapes to indicate what you're looking at here. So this is a bar graph that's telling us this is the resting blood pressure, and the orange line is this line graph, and that's the cholesterol that we're looking at here. All right, that's looking pretty good. Let's move on to our next section now. So this next section, you'll notice that we haven't added any titles, we haven't added any labels, we haven't messed with any of the text. We've just been doing the graphing, with the exception of our legend here, which gets placed automatically. So let's have a section now. And what section is it going to be? I think number 4, right? Are we on section 4? Yep, section number 4. Moving right along. Section number 4, adding and altering text. All right. So adding and altering text. This is a very important part of graphing because you want to give people information about what they're looking at. You want to label your x-axis. Like, what is 50? What does this number even stand for? You want to label your y-axis. What are we looking at? And then you want to give the graph some title, some helpful title, so that people are able to understand the context of the data and what you're trying to communicate. So I'm going to, before we do text, before we dive into it, I want to show you a very helpful Matplotlib resource. So if you do Matplotlib text API here, let's take a look at this. So there's one specific thing that I want to show you actually, and I'll just go ahead and copy in this URL. It's down here on the page. Here we go. Class matplotlib.text.text. So the reason why I'm showing this to you is because the Matplotlib, the API, the documentation, is very good for looking at all of the different properties that you can use when you're using something like a text object. So our titles are text, our labels are text, etc. These are some of the things that you can change about the text. So you'll notice you can change the font family, so you can change the type of font. You can change the font size. One of the ones that we're going to use is you can change the rotation of the text. So you've got all of these different options for manipulating the text. So this is a very helpful link. I'll make sure that you have this. And whenever you need to do something special with your text, you can come here and reference this. So I'll actually, I was going to paste this into the Jupyter notebook here. Okay, so first let's look at axis labels. And this is axis with an I as opposed to axes with an E, like that. So let's get some graph to work with that we'll work with for this text section here. So let's see here. Maybe what we want to do is we want to look at this bar graph of cholesterol. Well, we want to look at a bar graph of cholesterol by age. So I'll copy this plot down here. Let's change this to a bar graph of age versus cholesterol. I'll get rid of the color and the label. So first things first, our audience has no idea what these what the axis, the x-axis and the y-axis are supposed to mean here. So the way that we do that is I'll actually show you on the object first. So AX, I'll hit dot, hit tab. Let's look at all of our different methods here. So it's the set. So you'll start seeing all the different things that you can set come up here as I type in set underscore X. So you can set the bounds, the limit. We're going to set the X label. So we're going to set the X label here. And what is our X? Well, that's the age. So let's go ahead and copy this up here. And there you go. You see the word age printed down here now as our x-axis label. If we want to do the same thing for the y-axis, well, we just change this to set y label. And what is this? This is going to be average cholesterol. Average cholesterol there. And there is our y-axis label. So now what if we want to give this plot a handy-dandy title? So I will go ahead and copy this down. Let's create a new section header here called plot title. And the way that you do this is let's go back to ax.set and let's just see if there's a set title. Set, there it is right there. Look at that. I already knew that, but you didn't know that, so it was still a surprise for one of us. ax.set title, and let's look at let's say average cholesterol by age. And there you go. Average cholesterol by age now as the title of, and we're doing this on the AX object, so this is the title of this axis, the title of this axis, and this will actually come into play in just a second here. So these are two of the main things you're really going to want to know for adding and altering text, and we're going to do some more with text later in the common questions section. But for now, let's go ahead and just leave it as the axis labels and the plot title, since these are going to be some of the main things that you will use. All right, so let's get to our last section here before we get into common questions. And like I said, we're going to get back to text here quite a bit in the common questions. So we're going to look at things like changing these ticks and rotating the x-axis and y-axis labels and changing the font size and all of that good stuff in the common questions. But let's do one more section first of basic functionality before we get into some of the nitty-gritty here. So section number 5, using subplots. So I've already showed you this up earlier in the Jupyter notebook here, but I want to make it explicit and spend a little bit more time on it. So you know how we usually do plt.subplots, and then we do plt.show, and that creates a single axis here that we can plot things on. Well, if we pass in a number, so number of rows, number of columns, then we get multiple graphs here. And let's go over again. So let's take a look at a 2x2 here. And remember that this actually usually we'll change this to AXS if this has multiple axes in it. And if we look at AXS, this is a 2-dimensional NumPy array. So notice that here we have a list of 2 Matplotlib axes. Here we have a list of 2 Matplotlib axes, and these are both wrapped inside an outer list. And we can just look at the dot shape here and see that we have 2 by 2, which matches what we asked for and also matches the graph that we're getting. So then to plot on each one of these, essentially what you do is you do AXS, and then you can specify the coordinates within this AXS object, or the indices, the index of where you want to plot. So let's plot something in the first row, the 0th row, and column 1. Let's try that. And maybe we want to plot here. Let's take a look at our group by age again. So maybe we'll do all of these as looking at our age. And let's go back to looking at our cholesterol values. And here you go. You can see that we now have a line graph in the first row, second column, of our average cholesterol by age. Now, what if we want to look at, in this first one, maybe we want to look at the, 0, 0 for the 0th row, 0th column, maybe we want to look at a bar graph of the average resting, what was this? Resting blood pressure, right? Let's do a bar graph there. So now you'll see that we have a bar graph in that first plot there. And this is something that's going to come up in the common questions as well, but I'm going to go ahead and make the figure bigger. So remember that the figure is this whole image, right? And so now we're trying to plot 4 different graphs inside the same image, whereas before we were only plotting 1. So that's why this looks pretty small. So let's change the fig size here. Let's change the fig size, and maybe we'll make this, let's just pass in a 10 by 10 and see what that does. Or maybe, maybe let's try 12 by 8. There we go. That looks a little bit more proportionate. So now you'll notice that the figure here, this is still just a single image, but the single image is now bigger. So we have more space for each axis that we're plotting on. Okay, let's take this. Let's create 2 more of these. So we need to plot something down there in that second row, first column, and something in the second row, second column. So maybe let's take a look at our group by, what columns do we have? Let's take a look at this one for our third graph. And maybe let's take a look at this for our fourth. So we got Thalak here and Old Peak. What are those? So this one, Thalak, or however you pronounce that, is the maximum heart rate achieved. And Old Peak is the, what is this? ST, depression induced by exercise relative to rest. I'm not entirely sure what that means, but if you do medicine, you might know what that means, or if you're in healthcare. So let's make this third graph here a scatter plot, and maybe we'll make the final one a bar graph again. So let's try this, and here you go. So you see that first we're plotting a bar graph, and we can do anything that we want with this axis, just like we would with just a single axis. So we can set the labels, we can set the title, we can do all of that stuff. The second one, we have a line graph. We have a scatter plot, and we finish it off with another bar graph here. So let's take a minute to just show you that you can indeed set the X label and the Y label and the title just like normal using this axis object here. So let's look at the first graph, and then we'll do the second graph. And here's the third graph. And here is the fourth graph. All right. So, and we maybe don't need to set everything for all of these, but so rather than AX, I'm just changing it to the axes location inside of this NumPy array here. And the X label, well, this is going to be age. The Y label, this is going to be average. What was this? This was your resting blood pressure, right? So average resting blood pressure. And if we want to set a title here, we can say average resting blood pressure by age. Let's take a look at this and see how that looks. All right. So our graphs are getting kind of tight here, which, getting your graphs to look exactly the way that you want them to definitely takes some time, depending on what you're trying to do. But notice that we do have an X-axis label, a Y-axis label, and a title just for this graph. So, and we did that just by using this same axes object here. Now, let's say that you had taken the time to populate all of these graphs with their appropriate labels. So I'm going to go through and just make sure that this is indexing into the correct axes object here. So let's say that, we're just going to leave all these as the same for right now. But let's say that you took the time and went through and, maybe I'll change cholesterol. And let's see, what was this one again? This one was heart rate achieved average, maximum heart rate achieved. And remember, this is the average of all these because we're looking at the data grouped by age and then averaged. And then old peak, well, this was the ST depression induced by exercise. So we'll just say average old peak here. All right. So let's say that you took the time to plot all of these. Well, just like I was saying a second ago, the age x-axis label and the title here are too close. They're overlapping. And this doesn't look good, and you can't read it, and you don't know what that says. And so we need to fix this somehow. So there are ways of moving the text up and down and moving the graphs up and down. But there's also this very handy-dandy plt.tightLayout function. And this is it's not a magic bullet. It's not always going to work exactly how you want it to. But if you call this tight layout right before plt.show, then Matplotlib tries to do its best to make sure that things are not overlapping. And so you'll see here that the x-axis label and the title of the graph below are now not overlapping. and everything looks pretty good. Okay, so I think that that's it for section number 5, using subplots. It really is just this easy. You create however many subplots you want, and then you do any kind of graphs that you want on each subplot, on each axis there. Finally, you call plt.show, and if things are overlapping, try plt.tightLayout. Try this and see if that works. And if not, you might need to do some manual tinkering with the positions of things, but hopefully this works for you. Okay, so now we're going to go on to our last section here, which is a little bit of a longer section, and that's because, let's see, section 6 here, section number 6. That's because when we're talking about common Matplotlib questions, there are a lot of these because we've walked you through the basics here. You now have all the information that you need to be able to take your data and do some basic plots, some basic line graphs, bar plots, scatter plots, etc., and to set the titles, to set the X and the Y axis labels, to do multiple plots. You have all that knowledge, but typically whenever people are doing plots, they want to do something specific, and there are a lot of different specific visualizations and specific ways to alter a visualization that people typically want to do, that you might want to do. So this common question section here is going to go through a lot of the most common things you might want to do with your plot, starting with how do we change the figure size? How do we change the figure size? So this is something, and we're going to go back, by the way, to our X data and our Y damped oscillation data here, just to have kind of some consistent, and I'm actually going to set Y equals to Y damped oscillation so that we can just plot X and Y for all of these different plots here. So this is something that we did up above. Let's start with our normal template here, plt.subplots, ax.plot x and y, and then we'll do plt.show. Run this. Okay, so how do we change the size of this figure? Well, we can do that right here whenever we create the figure and the axes to begin with. So we just pass in fig size. It's as if you're specifying the size of a fig fruit, but you're not. It's the size of this figure here. And then you can pass in whatever you want. So let's pass in 10, 10. There you go. We get a nice big square figure here. If we pass in, let's say 12 and 8, so you'll see that this first number here controls the width of the image, and then the second number controls the height of the image. So that's how you change the figure size there. And let's make this a little bit smaller. We'll go 6 and 4, and we're actually pretty close to our original image size. So let's try 8 and 6. All right. So moving on to our next question. How do we save our image to a file? How do we save our image to a file? Well, you could just right-click here in Jupyter Notebooks and say Save Image As. That's a very easy way to do it if it's just a one-off thing. But if you want to save it to a file using Matplotlib, let's get our basic plot down here again. I'll remove figure size. So rather than calling plt.show here at the end, let's do plt. I'm going to hit tab and see what all of our options are here. And I'm going to start typing in save fig. There we go. So let's actually look at the documentation for that using our handy dandy question mark syntax in Jupyter Notebooks. So we can save the fig, and then it just says args and quargs. So, arguments, keyword arguments. So basically we can pass in anything to this. Okay, here's the call signature. So fname, so our file name. We can pass in the DPI if we want. We can pass in the orientation, bunch of different stuff. But the main thing that we're going to want to look at here is the file name. So if format is not set, then the output format is inferred from the extension of fname. So in this case, let's say we want to save this as a PNG. We can say myplot.png, and it will save it as a PNG because Matplotlib sees the extension here and knows to save the file as a PNG file. So let's go ahead and run this, and you'll see that it pops up here as well. But let's go back over to our terminal. Let's do a little ls, and there we go, myplot.png. Let's open myplot.png, and here is that image right there. Look at that. And so if you blow it up really big, you can see it does get a little fuzzy. That's where the DPI argument can come in handy. But we just saved out our image to a file. So there we go. I'm going to save this notebook really quickly. Make sure to save as you're going along so you don't lose your work. All right. Let's go to our next question. How do we change the font size? Title, axis labels, and tick labels. All right, let's check this out. So we've got our normal plotting formula right here. I'll remove the fig size. Okay, so we're going to plot. So first, let's set our title and our axis labels. So I'll do ax.setTitle, remember, and we can just say, damped oscillation. And we can do ax.set y label, and we can just say that this is the, let's just call it y label for now. Y label. And ax.set x label, and we'll just call this x label. All right, so we do that, and you'll see that Matplotlib goes ahead and puts a title, X label, Y label, but they are the default fonts here. And this, you can do this a lot of different ways. You can do this right here, which will be the way that I'll show you. You can just pass in some font parameters. So if we do font size equals 20, let's say, then there we go. Our title is now bigger. And we can also pass in font size for, let's maybe do 15 for these labels here. And there you go. You see that our X and our Y label are now different. And then for our tick labels, this is going to be a little different. So usually you can just follow this kind of formula here. For the tick labels, we're going to do something different. And that's using the AX, I'll come out here, AX dot, if you start typing T and then hit tab, this tick params here. So I start typing tick params. And let's take a look at this. So tick params changes the appearance of ticks, tick labels, and grid lines. And you tell it which axis you want to apply it to. So in this case, we can say AX dot tick params. Let's maybe say axis equals both. Let's apply it to both axes. And in this case, it's actually going to be label size. And let's set this equal to 10. Just to show you that it's working, let's set it equal to 30 at first. Okay, so that's nice and big. Way too big. Let's set it equal to like 7. So they're pretty small now. And I just want to remind you right now that the documentation is going to be your best friend. So in the case of text, for example, here are the different things that you can pass in for text. We passed in font size for the title and the X and the Y labels. We could also pass in, let's see, color. Let's just show you that really quickly. We can pass in color equals, red or whatever. And then if let's just Google, Matplotlib tick params, and this will take you to this documentation page right here. And you can maybe find a little bit more information. You could find some examples. You can see this example usage right here. this documentation is going to be very helpful for you, and also the documentation that you can find in Jupyter Notebooks just by doing the question mark. Most, if not all, actually, of the documentation from online for some of these things can probably just be found right here, like this usage right here. It gives you a nice example. So remember, if you have a question, consult the documentation, and because there can be a lot of different ways to do this. And I'm going to drop this as a reference here right now. We're not going to go into it too much because this could be a whole other conversation. But there is this idea of your RC params, and this is basically what this is saying is, this is going to set various parameters for different objects in Matplotlib for your entire plot or for your entire Jupyter Notebook session. And you can store these parameter defaults externally in a file and load them as well, so you don't have to do this every single time. So you don't have to constantly be specify what font you want and what size you want, etc. So for example, here's a font dictionary with the various parameters that we want for our font. We want the family to be monospace, we want the weight to be bold, and the size to be larger, that's kind of funny. And then you essentially say, I want to apply these parameters to all font objects. And this is how you would do that. So if you're interested in learning more about how to set these defaults and how to create your own Matplotlib parameter file, then definitely do some more research into that. We're not going to be going over that today, but I will drop this link right here for more research. And you'll be able to find all of these links outside of the video, by the way, in the video resources. Okay, moving on. So a very common question, and this is something that we did not use this method this way, but you might see something like this. What the heck does this mean? You might see fig.add subplot something like 111. So what the heck does that mean? Well, let's just try it and see what happens. So we'll do fig ax equals, we'll do this. So plt.subplots, and then fig.add subplot 111. Let's try that. plt.show. So this will actually be a little bit more clear if we take away our axes. So let's create a figure. Let's create a figure first. So fig equals plt.figure. But let's not create an axis to start. And I'm not going to use this add subplot either. So with just creating a figure and then doing plt.show, you see that we have a figure here, but there are no axes. And remember that the axes are where the plots actually occur. So we don't have anything that we can do any plotting on. So if you have a figure and you want to add an axis to it, that's where this add subplot command comes in. So now if I set ax equal to this and we run this, you'll see that now we have an axis. And if, just to be very explicit about it, let's print ax, and you'll see that this is an axis subplot type. We can even just print the type of this object. And this is of type, matplotlib, axes, subplots, axis, subplot. So basically what add subplot does is it adds an axis to the figure. So that's kind of step one here. So I'll say, first, fig.add subplot adds an axis to an existing figure. So then there's a question about what does this 111 thing mean? So I will admit this is very confusing. Let's just look at the documentation for subplot. And once again, kind of unhelpfully, we just have these args, quargs here, but let's look at the call signature. This is where the useful information is going to be. So add subplot, it looks like you have different options for using the add subplot method, and you do, in fact. So the first way you can call it is how many rows do you want, how many columns do you want, and then what's the index of this plot. So let's use that really quickly. So imagine that I say I want 2 rows, I want 3 columns, and this is going to be at index number, let's say index number 2. So it's hard to see. Okay, let's let's create a basic axes to work with first. So we'll do dot subplots here, and then we'll create a second axis on top of it. There we go. So this, hopefully this makes a little bit of sense here. So essentially what we're saying is we're creating our first axis, which is this graph back here, and then add subplot, we are going to imagine that we're creating 2 rows and 3 columns worth of subplots, and we're going to only create an axis at index number 2. So let's say that we wanted to demonstrate this a little bit more clearly. Let's also add, let's say axis number 3, and we're going to add this at index, let's say 1, 2, 3. Let's say add it at 4. So we're going to add it in this bottom corner here. And there you go. So add subplot is basically a way of saying, hey, I have a figure. I want to create an axis on it. And I want it to be in this specific location. And I want it to appear as if it's in, you know, a row of 2 rows, 3 columns, etc. So that's kind of one of the ways that we can use it here. Going back to the documentation, you'll see that we also can pass in just pose or x. So let's take a look at what those are. So POS, pose, position, is a 3-digit integer where the first digit is the number of rows, the second is the number of columns, and the third is the index. So this is why I think this is kind of confusing, because you can basically take these methods and just squish them down with no commas, and this is exactly the same thing. So we're saying, hey, I want to create subplots as if there were 2 rows and 3 columns, and I want to create an axis at index 2. We run this, we get the exact same thing. So if you see something like fig.add_subplot 111, well, what does that mean? Well, let's go back to just creating our figure. All right. So fig.add_subplot 111. So this is saying I want 1 row, I want 1 column, and then I want to create an axis at index 1 within this thing. So this is basically saying I want 1 graph, you know. Nothing too tricky there. And actually, this is the exact same as calling it with no arguments there. So I think this whole thing can be rather confusing. Personally, whenever you have the option to create subplots in the very beginning here, whenever this makes sense for you, I would say do it this way. Do it this way. And then you get your list of axes objects there, and then you can, you know, you can manipulate them individually that way. If you really like using this way, that's fine, but just know that there are kind of a lot of different ways that you can do this, and it can get very confusing. So try to pick one way and stick with it. And I would recommend just sticking with this to begin with. And by the way, just to show you that we can, in fact, plot on those axes just like we would plot on any other axis. So I'm going to do ax equals fig dot add subplot. Ax dot plot, let's do x and y. Let's create another one. Ax2 equals fig dot add subplots. Let's create 2 rows, 3 columns. We'll do index 3 this time. And then ax2 dot plot x, y. And there you go. We got our big graph, which is this first one that we created, and we got our small graph, which is that second one that we created. Okay, let's move on. Another common question is this one. How do I change the tick frequency? The tick frequency on the x or y axis. All right, so let's go back to our normal way of doing things. Subplots. Subplots, we'll do ax dot plot x and y, and then we'll do plt dot show. So you'll see here that the current x ticks are basically just where Matplotlib thinks that they should go. And sometimes this will work, and sometimes we'll want to change that. So if we go up here to ax dot, I'll hit tab, take a look at what we got here, and then I'll start typing in set, and you can see all the things that we can set. And let's scroll down, and you'll see set x ticks. This is the one we want to go for. We can look at the documentation if you want. So we basically just pass in ticks, and we just pass in a list of x-axis tick locations. So let's try that. Let's say we want tick locations at, let's say negative. Let's change this from even numbers to, let's say, -5, -3, -1. We'll add 0 as well, and then 1, 3, 5. Let's see what happens. And there you go. We have now changed the x ticks from even numbers to odd numbers, including 0. And we can just leave out some of these tick labels if we want. You know, let's take out 3. And there you go. Like maybe this is how you want to present it for some reason. And you can even do stuff like, let's add in -10 for some reason. And, you know, there you go. So you've now kind of expanded the graph to the left and added an X tick label there. So it's just that easy. And you can, you know, you could do all kinds of different patterns and stuff with this if you want, but that's how you do that. All right, this next one is one that I use pretty regularly. So how do you set the y-axis limit? So whenever you have a normal graph like this, Matplotlib just tries to determine what kind of y-axis you want, and sometimes that'll work and sometimes it won't. So the way that we can do that is if you do ax.set, and then let's just try to set y_lim. There you go. So y_lim, you can pass in the bottom, you can pass in the top. You've got some other options here, but the way that I typically like to use it is you just say ax.set y_lim, then you pass in a minimum and a maximum. So maybe we want to look at this from 0 to 150. And there you go. That's what this graph looks like from 0 to 150. Or maybe we want to look at it, you know, from -100 to 100. And there's what that looks like. So you can use this set y_lim to shrink or grow your y-axis. Okay, these next two I think are pretty cool because they're a nice way of kind of cleaning up your graph by removing things if you don't want them. So I do use these sometimes as well. So let's say, how do you remove ticks and tick labels? So let's get our plot here. And in this case, we are going to go back up to this set x ticks method and set y ticks. Set x ticks. And we're just going to pass in an empty list. And there you go. So we're basically saying, you know, hey, we don't want to plot any x tick labels. We can do the same thing with y. And we can just make this graph totally contextless, which is, you know, admittedly not very helpful, but it does look nice and clean, doesn't it? So, you know, if you want to do this for any reason, there you go. There you go. So related to this, how do you remove the axis lines, grids, etc.? So let's say that we want to remove these lines around the edge. Well, let's get our normal plot up here. Delete these. And if you come in here to ax.set and then set axis off. Ta-da! So let's try that. See what happens. Set axis off. And there you go. No axis lines around that. Now, by the way, we didn't have any grid lines here, but if we did, this would affect the grid lines as well. So let's actually show that really quickly. If we do ax.grid and then pass in true here, we get this nice grid at the tick marks. And now if we do set axis off, so this not only turns off the lines around the graph, but it also turns off those grid markers. Okay, next question, rolling right along here. So this is a very common one. How do you rotate axis text? And this isn't something that we've had to use really because our axis text has looked fine, but a lot of the time you might have very long labels here and they all run into each other and you can't read anything. And so you're like, well, I need to rotate these so that I can see them. So I'll show you how to rotate your axis tick labels. And we're going to go back to our friend, the tick params method. So ax.plot, xy, plt.show. All right, let's rotate these x-axis labels. So we're going to go back to ax.tickparams. And if you look at the documentation, or if you remember, you can remember that we can pass in which axis we want to do it to. And then we can pass in any parameters that we can apply to these labels here. So I'm going to pass in the parameter rotation equals, let's try 45. And there you go. Now they're nice and rotated, and if these labels were very long, they would not run into each other. Okay, we're getting closer to the end here. We've got a few more questions to go through, though, so let's keep rolling. Scatterplot marker size, or let's change this into a question. How do you change the scatterplot marker size? So let's get our graph here. In this case, we are going to need to change this to scatter. Look at that. So remember that we had like 1,000 points here that we're plotting. So that's why you see so many different points here. So for the size, well, let's just look at ax.scatter. This is a great habit to get into, by the way. Just look at the documentation, check out what the parameters are. This will help you a ton. Okay, so we're going to be going for this S parameter here. And if you look down here under parameters, S, the marker size in points squared. Okay, cool. Let's just tinker with it and see what happens. You can also pass in an array-like, so you can pass in a shape for a size for every point. But let's just start by passing in S equals, let's try 10. What does 10 do? 10 makes it smaller. So if we can go down to 5, even go down to 1. Look at that. And then we get these kind of really tiny little points here. So we can change the size that way. What if we wanted the size to vary with the x-axis here? So as our points have larger x values, maybe they get bigger. Let's try that. Hey, look at that. So they start off really small. And actually, I think we do have a point of 0 in here, which is probably why this is, invalid value encountered in the square root. So we might be, let's try adding a very small value to this, like 0.1. There we go. That fixes it. So you can see here that our sizes start out very small and then they get bigger as we go along. And so this can lead you to do some kind of, cool effects. I don't know if they'd be useful for what you're trying to plot, but they can look pretty cool at least. Let's even do x plus 0.1. Let's multiply by 10 or something so we get really a bigger effect. There we go. Or we could pass in y, for example. And it looks like because we can't have negative sizes, now we're only showing the points for the positive y. So maybe we make this absolute value of y. So that looks pretty funky. Or we could do, what does this go down to? Like negative 100. So we could do y plus 105. There you go. And this is kind of big. So, we're just tinkering around at this point. This doesn't necessarily, yeah. So there you go. You got your size option. And by the way, this is going to be how you would do this across kind of a lot of different graphs and actually, in fact, some other plotting libraries in Python as well. So that's why I wanted to show you this, that you can pass an array here for the size. And you can also do the same thing for color. And let's actually show you that really quickly. This will be our next question. How do you color and size every individual point? Well, you just pass in arrays. Here. So let's take this. We'll take it back down here. Let's get our x. We'll do x plus 0.01 or 0.1 to avoid that whole error that it encountered, and we'll multiply that by 10. And then we've also got this c parameter. So let's try passing that in. Let's try passing y in for that. And you'll see that we get some kind of interesting thing going on here. Let's I'm going to pass in a C map value. This is a color map. This is a way that you let Matplotlib know, hey, I want to use a particular group of colors. So we got some cool warm going on. And this actually is not doing what I would expect it to do. I would expect the values to change with the y here. Let's take a look at ax.scatter. So you can pass in size, you can pass in C. C is a color, a sequence, or a sequence of color. There we go. All right, it looks like was able to fix it by some of these x values. If you look at x here, so we're going down to -5. And so if we add 10 to our x so that we make sure all of our sizes are positive, then it looks like things work as we would expect them to. Okay, figured that out. So this is coloring by every point and also doing the size by every point. And this might not be very helpful for this specific graph, but let's say that you've got, 100 different points on a scatter plot and you want to color them by one thing and you want to size them by another. This is how you would do that. And as we just learned, make sure that all of your sizes are positive because you can't have a negative size. All right, here's one that comes in handy for some data science problems, and this is how do you plot using a logarithmic axis? So essentially, sometimes you might have values that grow very large very quickly, that grow exponentially. You might have a histogram where everything is clustered over on one side. So these are a couple of the different use cases where you might be interested in using a logarithmic axis. So I'm going to just copy over some code that I have over here. So our x exponential is just going to be an x range from 1 to 10 with a step size of 0.1. And then our y values, so we're going to do the exponential function. So e to the x times 30. So e to the x times 30. Now, if you plot this, you'll see a graph that looks like this. Now, this is not particularly helpful, right? We are down here. It looks like very close to 0, and then suddenly it just shoots up. But you'll see that our scale of our axis here, our y-axis, is actually, what is this, like 10 to the 129. So this is a monstrously large number. It's just the fact that our y values are growing. They grow so large towards the right side of the graph here that none of this is really on the plot. So this is not particularly helpful. So how might we change the y-axis to be a logarithmic axis? So this is a kind of a classic example of when you might want to use a logarithmic axis, is whenever you have some of your values that are in wildly different ranges than other of your values. So in this case, we come down here to where our axis is, our axes, apologies. Ax dot, in this case, we're going to use this set y scale, and we just pass in log. And there is a beautiful straight line that shows the linear relationship between x and log of y. So this is a nice thing to do for graphs like, let me copy this up here just so you can have a reference. It's a nice thing to do for graphs like this. As I said before, it also is nice for histograms where you have a lot of values kind of clustered on one side. So, and this is a pretty common thing that comes up in data science as you're looking at different types of data. Okay, rolling right along here. How do you plot two histograms on the same chart is a pretty common question. This is something that you should know how to do. How do you plot two histograms on the same chart? This is something you should know how to do because it is a classic example of plotting two graphs on the same axes. So let's see. So if we just plot our x and y here, so we're going to need some data that we can plot in a histogram. And I went ahead and created a couple of normal distributions. Let's go ahead and throw those in here. So I'm just creating normal distributions. They have a certain mean, they have a certain standard deviation, and I'm creating 1,000 different data points. So if we do ax.hist of dist1, let's create these outside here. So we're dealing with the same data because this will create a new data set every single time. And here's our first histogram. And now you just do another histogram on that same axis. So ta-da, there you go. Two histograms in the same chart, same axes. It's as easy as that. Now, whenever we've got something like this going on, I'll show you another one of my favorite tricks here, which is using this alpha parameter. And alpha basically controls the transparency. So let's actually do alpha on the second graph first. And let's take this down to like 0.7. And if we take the alpha down to 0.7, you can now see that we can see through the orange graph to the blue graph. And if we do an alpha on both of them, then we get this pretty nice coloring effect here where both of them are a little bit muted and we can see the distribution of both of the graphs. Now, just because I think that this is helpful, I'm also going to throw labels on here. So dist1, dist2, and then remember if we run this, this doesn't do anything until we call ax.legend. And there you go. That's how you do two histograms on the same chart. All right, just three more questions. This is a marathon, isn't it? All right, so how do you draw horizontal and vertical lines? So you might want to draw some reference lines for people to look at for various places in your graph. So let's let's come up here. We'll get our little template. We'll do ax.plot x and y. All right, so let's say that we want to draw a horizontal line at 100, a horizontal line at, let's maybe do 50 and negative 50. And then let's also do a vertical line at negative 4. So how do we do that? Well, these nice little ax.h lines function and ax.v lines function. So let's look at the documentation for h lines. So you pass in ax.h line. So you pass in y, which is a scalar or a sequence of scalars. This is the y indexes where to plot the lines. So we're going to say we wanted it at negative 50 and 50. And then you also have to pass in the x min and the x max. So do you want the line to go from negative 4 to 0? Do you want it to go all the way across the graph? And in this case, we want it to go all the way across the graph. So I'm actually just going to say, give me the minimum of my x data and give me the maximum of my x data. And there you go. So we're going from the minimum of our x up to the maximum of our x. And if we wanted this to go, shorter for some reason, well, we could have it go from 0 to 5 or whatever. Okay, and then the same exact thing for ax.v lines. So in this case, we just want a line at negative 4. And let's go from the minimum of y to the maximum of y. And there you go. And if you want, you can pass in colors. So you can pass in colors equals red, or you can pass in a list of colors. So let's say red and blue. And there you go. So now we're coloring our lines by different colors there. Okay, 2 questions left, and I saved 2 of the cool ones for the end. So we're going to talk about images, and we're going to talk about colors. So how do I display an image using Matplotlib? How do I display an image? So this is pretty common. You might want to do this especially with neural networks, with deep learning. If you're dealing with image data, you might want to look at some samples of your data in a Jupyter notebook. So let's go to an image which I think is very beautiful. So I'm going to get an image from Unsplash. Unsplash has a lot of really nice photos on there. You can download them. They've got the art, the photographer who took the photo. So you can go to this photo if you want, which has this URL here, this funky looking URL, or you can find your own photo on Unsplash. That's totally fine. And let's go ahead and download for free. Thank you to, Yuri, MLCN on Unsplash, for sharing your work with us. We're just going to use it for a minute. All right, so let's close this out. Let's go back over here. Let's actually go to our terminal. And we're going to need to move our, downloads, our image file from downloads. So if I do ls tilde for home and then downloads for our downloads folder here, you'll see that here is our JPEG that we just downloaded. So let's move mv from the downloads, Yuri, into the current folder where I'm at. If I do a little ls, you'll see that I just moved that image here. Perfect. So how do you display an image in Matplotlib? Well, if you look, this is going to use the PLT, the pyplot module here. So plt.im for image read. im read. So if we read in the image, so we have an image, it's a JPEG. Let's read in our image here, and let's just call it image. Oop. All right, so it looks like we can only use PNG files without Pillow installed, but if we install Pillow here, then we can handle more images. So let's just hop over to, and actually I'll show you how to do this in Jupyter Notebooks. You don't even need to leave Jupyter Notebooks necessarily. So let's say which pip, and our pip is going to be the one from our virtual environment. So let's do pip install pillow. Let's try that out. There we go. It's that easy. Very quick too. So I'm going to go ahead and delete this cell. Let's try reading it in again. And there we go. We read it in successfully this time, now that we have pillow installed. So what's the type of this object here? Well, this is a NumPy array. So if you already have an image file that you want to read in, you can use plt.imread, and that will convert it into a NumPy array. If you already have a NumPy array where your image is stored, then you're good to go. And let's take a look. Let's take a look at our image data here. All right, you can see that we've got some nesting of these square brackets. So this is going to be a multi-dimensional array here. Let's look at the shape. Let's look at the shape. So here we go. We have one dimension of our image. We have another dimension of our image. And you'll see that our third dimension is, this is going to be our RGB values. This is going to be the color of the image, essentially. So let's show you how to plot that. Let's do our normal template here. Normal formula, plt.subplots, and then plt.show. And then in this case, we're going to use a special method called imShow. And we are going to pass in our image there. And look at that. It's kind of small, and it has an axis, or it has your x-axis and your y-axis there. But this is our image. That's pretty sweet. I think that's pretty cool. So I'm going to turn off the axis, and I'm also going to specify a larger fig size. Now, in this case, I want the same dimensions as the original image. So I'm going to say image.shape 0. And then since this is going to be this large number here, maybe I'll divide this by, let's divide it by like 300. Image.shape 1. Divide that by 300. And there you go. We have a much bigger image, and the axis, the y-axis and the x-axis are turned off. So that's how you display an image. Now, I want to show you a couple of other cool tricks really quickly while we're here. And that's how you can display just one of the RGB channels using Matplotlib here. So let's go back up here. Copy this, come down. So now, instead of plotting the whole image, let's plot all of the rows of pixels, all of the columns of pixels, but let's only plot the first of the RGB channels. So I think this will probably be the R channel, the red channel. And let's take a look at what that gives us. Wow, look at that. So this adds a color map to it. So this is going to add a color map by default. These are actually just single valued pixels. So you can think of it as kind of a black and white image here, but then Matplotlib chooses to add a color map to it, the default color map here. So what if we actually wanted to see this as a grayscale image? Well, that's where this nice CMap parameter comes in again. We say CMap equals gray, and now we have that nice grayscale image. And this is, remember, this is just using the single channel, the red channel, I believe. So let's try another channel. And this is where you can get into some really cool image analysis stuff. So this is a different channel of the image, and you can see that you can see a lot of different detail based on what the original color was. So in particular, notice up here how this is very dark up here on the top left, and then up here you've definitely got a lot more light going on. And in this first image, the land here is much brighter than it is in the second image here. So that's how you can start doing some cool image analysis using Matplotlib. And you can, this is just a NumPy array. You can go in there and you can edit this however you want. You could feed this through a convolutional neural network, do some machine learning, do some deep learning on that, and plot your results using Matplotlib. All right, our last question, and that is, how do I find what colors are available in Matplotlib? This is a great question because this whole time, we've just been doing CMap equals gray and colors equals R and B, or you could type in red and blue, and it can be very confusing. So from Matplotlib, let's import colors, and we're going to import it as mcolors for Matplotlib colors here. So if we do mcolors, do some documentation, you'll see that the colors module is a module for converting numbers or color arguments to RGB or RGBA, and it also includes functions and classes for color specification. And if we do mcolors dot and then hit tab, you'll see some things that look like list of colors here. So let's check out base colors. Look at that. We got our B, we got our G, we got our R. K is black over here. If you keep scrolling down, CSS4 colors. So this is a huge list of colors here that you can use. You can use any of these in Matplotlib. If we scroll all the way to the bottom, you'll see one of my favorites, XKCD colors. Check that out. This is from a great XKCD comic. If you have not, just Google XKCD colors, and you will find what that is talking about. But if you go to the C names, now this is going to be kind of the huge list of a lot of the standard colors in Matplotlib. And there's actually someone on Stack Overflow who did a really nice visualization of these different colors. And I'm going to paste this link here so that you can check it out. But this is the very last thing in the video. Very last thing. We're done. Yay! We're done. I'm going to show you this beautiful representation of a lot of the named colors in Matplotlib. So let's copy this code over here. This is kind of a lot of code, which is why I'm not going to type all this out for you. And check that out. All of these colors with their names that you can use in Matplotlib. Pretty beautiful, I would say. Pretty beautiful. And that's it. We're done. What a marathon of a tutorial here. That was a lot of information. Don't feel bad if your brain feels like it cannot hold all of it. I'm going to leave you with a little bit of homework. Are we up to section number 6? Is that where we are? Oh, does it even matter at this point? Let's go here. Section 6. So we are now at section 7, actually. Section 7, here's some homework for you if you want to keep learning about Matplotlib. So, number 1, get your own data set to play around with. We got to change this to a markdown cell. Change that to a markdown cell. Or actually, let's just use the one that we got going on right here. So you learn better whenever you're interested in what you're doing. So get your own data set that you're interested in and try plotting some things. That will be a great way for you to learn. And I'll say here, kind of a little sub-bullet of this is with your data set, try going back through all of the things we did. And that will help solidify a lot of this knowledge in your mind. The next thing I would recommend is read through some of the Matplotlib documentation. And I'm going to point you to 2 specific places here. So the first one is the Matplotlib tutorials. Those are really good. They can help reinforce a lot of the stuff that we just went through. And the next one is the examples. So just looking at some examples and the code that generated those examples. And the final thing, which I will recommend, is reading about or let's just say learning about the PLT style or the state-based style of using Matplotlib. So this is kind of a way of using Matplotlib that we did not go into. I don't necessarily even recommend that you use this style most of the time. I think that the way that we've been doing things is how I would recommend doing them. But other people are going to use this, and you're going to see code examples that use this. And so it's good to at least learn a little bit about what it is. And with that, I want to say thank you so much for going through this tutorial. I hope you've learned a ton and are able to apply this to your own data science work. And if you need additional data science tutorials, definitely check out other project data science videos and courses, and leave a comment. Let us know what you want to learn, and we'll help you learn it. All right, that is it. Happy learning, project data scientists, and we will see you later. Bye.